Good morning, guys. Today, let us discuss about an important concept, which is knocking. What is that? Knocking. What is knocking? An irregular sound, an irritating sound, a metallic sound which is obtained in a ICE engine is nothing but knocking. What is that? Knocking is nothing but a sound, a metallic sound, an irritating sound, an irregular sound due to the movement of piston in the ICE combustion engine, ICE engine, internal combustion engine is nothing but knocking. So before going to learn about knocking, what causes the irritating sound in the internal combustion engine? Okay, you will find the answer, but before that, to understand the concept, you should know what is the working of internal combustion engine, ICEs. You should know the working principle of internal combustion engine. So the internal combustion engine will be like this. Okay, this is just a block diagram to make you understand. Okay, so this is cylinder, this is piston. Okay, yeah, this kind of internal engines will be there in our bikes, right? So how it will work? Let us see. Actually, this internal combustion engine generally called 4-stroke engines. What is that? There is a category of 4-stroke engines. What are 4 strokes? What does it mean? 4 strokes. Okay, there are 4 strokes. Okay, stroke 1. Okay, this is nothing but suction stroke. Suction stroke. Second one is compression stroke. What is that? Compression stroke. Third one is power stroke. What is that? Power stroke. The fourth one is exhaust stroke. Exhaust stroke. Okay, these are called 4 strokes. These are called 4 strokes. So in this topic, in our today's topic, okay, let us see how this internal combustion engine works, right? So in order to understand the working of a 4-stroke engine, first you should know what are the 4 strokes: suction stroke, compression stroke, power stroke, and exhaust stroke. So first one, what is suction stroke? In fuel tank, the fuel tank contains fuel. The fuel will be sucked into the internal combustion engine first. The fuel will sucked into the internal combustion engine first. So if how the suction takes place? Generally, for example, imagine that the piston is here. Okay, imagine that the piston is here. When the piston is moving upward direction, then the fuel will enter into the engine. That is nothing but moving the piston upward direction is nothing but sucking fuel from its tank, its reservoir. That is called suction stroke. That means piston moves upward direction by sucking fuel from its fuel tank. Is nothing but suction stroke. When fuel enters into the that means into the engine along with the oxygen, okay, along with the oxygen, then what happens is, now piston will move downward direction. Now the piston will move downward direction to apply pressure on the fuel present inside the engine. Okay, so applying pressure with the help of piston on fuel is nothing but compression stroke. Then what happens is, when this fuel generally in volatile state, when piston putting pressure on the volatile stated fuel, okay, then some amount of pressure will be generated, along with that temperature produces, then the fuel become more volatile and more active. At that active state, okay, we are giving power with the help of a sparkle plug. Okay, we are giving some amount of flame with the help of sparkle plug. Okay, when the sparkle plug, okay, gives some sparkles, it will be taken by the activated fuel that starts combustion. So combusting fuel with the help of sparkles, okay, through sparkle plug is called power stroke. Then what happened is, when the fuel combusts, it liberates high thermal energy. When thermal energy liberated more, it causes more pressure. The caused pressure will then work on the piston in pushing it in upward direction. Okay, so that stroke is called power stroke. Okay, then what happens is, after combustion, along with the thermal energy, some gaseous molecules also produced, kind of carbon dioxide, because fuel contains carbon. The cylinder in itself contains oxygen. When it undergoes combustion, carbon reacts with oxygen in forming carbon dioxide. Now the piston again will come down. Okay, so when it is coming down, okay, it pushes pressure on the produced gaseous molecules to send them out. That is called exhaust stroke. Do you understand? There are 4-step mechanism. First, piston is at this position. At the to the end. Okay. First, what happens is, in the first step, piston moves upward direction. Okay, piston moves upward direction. That is one stroke. When piston moves upward direction, what happens? Fuel enters into the engine. That is called suction stroke. Why we called it suction stroke means, when piston moves upward direction, it sucks the fuel from its fuel tank into the engine, into the ICE, right? So that's why we called it as suction stroke. Next, what happens? Now the piston is at top. In this step, piston is moving down to put pressure on the fuel present inside the internal combustion engine. Okay, to put some pressure on the fuel to activate the fuel. Here we are putting pressure with the help of piston on the fuel to activate the fuel. So this is called compression stroke, second stroke. This is called compression stroke. So in the compression stroke, what happens is piston working on fuel. Piston is working on fuel. Okay. Now after putting pressure on the fuel by the piston, okay, the fuel become compressed, okay, and become into highly activated state. At that activated state, okay, we are giving flame through sparkle plug. Okay, after taking flame by the activated fuel, it starts burning, it starts combustion. Okay, during the combustion process, it releases high amount of thermal energy. The released thermal energy creates high amount of pressure. The produced pressure will then work on the piston. In pushing it up. So that is called power stroke. Now the piston is at top position. Okay. So when the fuel combusts, okay, it releases some gaseous molecules like carbon dioxide. The presence of carbon dioxide is not good, right? So we need to push them out. So piston is coming down in pushing them out. So this is called exhaust stroke. So stroke 1, stroke 2, stroke 3, stroke 4. This is called four stroke. First one is suction stroke, second one is compression stroke, third one is power stroke, fourth one is exhaust stroke. So initially piston is like this. Okay, okay, first piston moves upward direction, then fuel enters. Okay, now piston is putting pressure on the fuel. Okay, this is second stroke. This stroke is called compression stroke. The first one is suction stroke. Okay, now after compressing the fuel, okay, we are giving some amount of heat to it through the flame, okay, with the help of sparkle plug. Then it starts combustion, okay, releases thermal energy, high amount of thermal energy, and produces high pressure. Then the produced pressure will push the piston again upward direction. This is third stroke. This stroke is called power stroke. Now the cylinder contains gaseous molecules. In that gaseous molecules, some unwanted gaseous molecules will be there, kind of carbon dioxide. They need to be sent out, right? So we need to put again pressure on the gaseous molecules to push them out. So piston comes down. So this is fourth stroke. This is called exhaust stroke. So first moves up, suction stroke, moves down, compression stroke. Okay. After that, we will give some amount of flame, okay, through the sparkle plug. Okay, combustion starts, right? So that causes a high amount of thermal energy generation and pressure generation, which causes moving up of piston upward direction. This is third stroke, power stroke. Now again piston moves down. Okay, why? To push out the gaseous molecules produced inside the cylinder. Okay, so moving up, moving down, moving up, moving down. Four stroke mechanism. This is four stroke mechanism. Excuse me. So we need to learn the mechanism of internal combustion engine working. Okay, here there is a relation between the concept knocking and the working principle. Okay, let us see. Initially the piston is at this position. Okay, so calculate the volume of gaseous molecules. What is this? Volume of gaseous molecules. Okay, name it as X. After that, piston moves up. Okay, then we will have another volume of gaseous molecules. Volume of gaseous molecules. Gaseous molecules. Okay, call it as Y. Okay, when the piston is at this position, okay, so this is the volume of gaseous molecules, that is denoted with Y. When the piston is at this position, this is the volume of gaseous molecules, that is denoted with X. Okay, what I want to say is, when piston moves here from this point to this point, okay, this is called suction stroke. This is called suction stroke. In this suction stroke, calculate the volume of gaseous molecules and denote it as Y. After that, the piston is moving down. Okay, the piston is moving down. When the piston is at this position, this is called compression stroke. At the compression stroke, we calculated the volume of gaseous molecules. It is denoted as X. Now, take the ratio. The ratio is called compression ratio. What is that? Compression ratio. This compression ratio can be constructed by taking the ratio of volume of the gaseous molecules at the state of suction stroke to the volume of the gaseous molecules at the end of compression stroke. So, volume of the gaseous molecules at the end of suction stroke is Y, and the volume of the gaseous molecules at the end of compression stroke is X. Understand, guys? Volume of the gaseous molecules at the end of the suction stroke is Y. Volume of the gaseous molecules at the end of the compression stroke is X. If you take this as a ratio, that ratio is called compression ratio. What is compression ratio? Compression ratio can be defined as the volume of the gaseous molecules at the end of the suction stroke to the volume of the gaseous molecules at the end of the compression stroke. So, this is the volume of the gaseous molecules at the end of the suction stroke. Okay? And this is the volume of the gaseous molecules at the end of the compression stroke. If we take the ratio of in between the two volume of gaseous molecules at the end of the suction stroke to the compression volume of the gaseous molecules at the end of the suction stroke to the volume of the gaseous molecules at the end of compression stroke. Okay, that ratio is called compression ratio. Okay, for a efficient internal combustion engines, for a efficient internal combustion engines, the compression ratio should be high, but should not be very high and should not be less. Always A very good efficient internal combustion engines have, okay, high compression ratios but not very high compression ratios. This is the preliminary condition, right? So again there is a question, what is a link in between this compression ratio and our concept knocking? Our concept knocking. Yeah, coming to the point. If the compression ratio, is like this, I am demonstrating like this. See here. Yeah. So this is at the end of the compression stroke. This is at the end of the suction stroke. Now this is the volume of gaseous molecules at the end of the suction stroke. This is the volume of gaseous molecules at the end of the compression stroke. Okay. So if the compression ratio is high, okay, that means the volume of the gaseous molecules at the end of the suction stroke is high. Okay. So in this case, generally consider, if the volume of the gaseous molecules at the end of the suction stroke is very high, okay, the piston should move like this. Okay, this is not good one. Okay, not like that. Take another one. Now the volume of the gaseous molecules at the end of the suction stroke is this only, not this. Okay, here. Okay. So if the volume of the gaseous molecules at the end of the suction stroke is this, and the volume of the gaseous molecules at the end of the compression stroke is this, that means what is happening here? When the volume of the gaseous molecules at the end of the suction stroke is at this point, means here the combustion is taking place high, and that during the combustion process the released thermal energy and pressure causes the movement of piston, right? Okay, which causes the movement of piston in an irregular order with low volume. Okay, the piston moves up and coming down very quick. Okay, what causes the quick movement of piston? What causes the quick movement of piston? That is due to, okay, the thermal energy produced inside the combustion engine. Okay, high amount of thermal energy produced. The high amount of thermal energy caused the piston to move up and coming down with a random order, irregular order. Okay, so due to the irregular movement of piston, which causes a metallic sound. That metallic sound is nothing but knocking. So knocking is due to the irregular movement of piston. The irregular movement of the piston is due to the improper combustion of fuel. The improper combustion of fuel changes compression ratio. Okay, the changed compression ratio causes irregular movement of piston. The irregular movement of piston causes metallic sound. That metallic sound is nothing but knocking. So to understand what is knocking, okay, you should know the compression ratio. To know the compression ratio, you should understand the working of internal combustion engine. Actually, this is not there in your syllabus. If you don't aware of the working principle of internal combustion engine, you will not know about the compression ratio. If you don't know about the compression ratio, you cannot understand what is knocking. Hope you understand what is knocking. Right, guys? Thank you.